Hello and welcome to Plutus Project-Based Learning 2024 from Gimbalabs and Friends. This is lesson 202.4, and in this lesson you'll learn how to mint native assets based on conditions in a minting validator. Now, we've already been minting new tokens in this module, and in the last two lessons, 202.2 and 202.3, we created some simple minting policies that use native scripts. But native scripts are not the only kind of script on Cardano. The other type of script is a Plutus script, and you'll often hear these referred to as minting validator scripts. Part of the reason for that is what you learned earlier in this course. When it comes to writing on-chain Plutus code or untyped Plutus core, UPLC, there are several different languages that all compile to UPLC. So even though we're talking about Plutus, the on-chain language, you can write a minting validator script in Aiken or Option or Plutus or Helios or other options. Okay, so we're talking about minting validator scripts. We're going to look at one in this lesson that was originally written in Plutus, but just know that everything I'm showing you here is also possible in Aiken or in other programming languages. Once we have a Plutus script, we're going to build transactions. And so just to review, this is the transaction we built in lesson 202.2, where we were minting a certain quantity of a token with a certain policy ID, and we gave it a name that was the token hex. We specified a minting script file. This was a native script. And then we had to specify the required signer because that's what this native script called for, an extra signature corresponding to some minting keys that we had created. When we signed the transaction, we needed both signatures. The sender key, right, which is the owner of the UTXO we were spending right here, and then a minting key to satisfy the logic in our minting script. In this lesson, we're going to do something similar, but look at these differences and see what you can find. There's a few things I want you to know. First of all, notice that there's no required signer like this down in this Plutus transaction. That's because the Plutus script we're going to use doesn't require any additional signatures. It's possible to write a Plutus script that requires other signatures. This example does not. Another thing you might notice is that we have to specify collateral because this is a validator transaction, so that's always going to be required. And this is similar to what you saw in Module 102 when you built your first smart contract interactions. And finally, in this transaction, we have to specify a mint redeemer value. There are several different types of redeemers. One is this one right here where it's a value, but it's also possible to specify a redeemer in a file or an object, a data object of arbitrary complexity. We're going to look at all of those details later when we get to validator essentials right here in Module 205. But for now, let's just look at the process and the possibility that we get from minting tokens based on Plutus validation logic. We're going to do two things in this video. First, we're going to see how to compile this minting script using Demeter run. And then we're going to use it with a script that's provided in the PPBL 2024 transaction examples repo. There's a link directly to it right here. So first, let's open up a Demeter environment, take a look at this code, and make sure that we can compile it. I have my Demeter console here. I'm running the repository PPBL 2024 Plutus examples. You can find this repo in the starter kits section of the Demeter site. So there's lots of useful starting points for building on Cardano. This is one of the greatest resources in the ecosystem. And one of the starter kits is the one we're using right here, PPBL 2024 Plutus examples. If you have a Demeter account, go ahead and deploy this. And it'll take a few minutes to provision right here, but once it works, you'll see that your instance is running, and you'll be able to click the Visual Studio Code icon to open up the code editor directly in your browser. One more thing to notice here, I also have a pre-prod node running in association with this Demeter instance. This allows me to build transactions in the web UI without syncing a node locally. Let's jump into the code editor. I'll click this button, and here's Visual Studio Code. To open the terminal window at the bottom of the screen, I'm going to hold the Control key and press the backtick button to open up the terminal. And once I'm here, there's two commands I'm going to run. The first is Cabal update. And this is going to make sure that my package lists, as you can see right here, are all up to date. Then I'm going to run Cabal REPL to open up the interactive REPL. The first time you run this, it might take a while, and it might even crash the first time, because provisioning this code for the first time places a heavy load on the Demeter servers. So if you try to run Cabal REPL, it takes a while and then stops working. Don't be alarmed. It's happened to all of us. Just try again, and it should work the second or third time. Because I've run this recently, my REPL loads very quickly, and this is what you can look forward to after you run it for the first time and everything's loaded in. Now, let's look at the project structure for just a minute. In the source directory, I have 4 subfolders: contributor token, faucet, which we looked at earlier in the course, the PPBL always succeeds, just as an example. And the new one here is minting. We have a secret number policy. All of these are exposed in the PPBL 2024 Plutus examples.cabal file. When I scroll down to the bottom, you can see it says exposed modules. And then I have the name of the directory, dot the name of the file. So ppbl.always-succeeds and .compiler, faucet.compiler, types and validator, and so forth down to the bottom where we have minting.secret number policy. Let's take a look at that file. We're importing different Plutus dependencies, but all of the action takes place right here. We're writing a function called makePolicy that takes an integer and a script context as parameters and returns true or false, a Boolean. The integer is our redeemer, and we can give it any name we like, in this case, _redeemer. And the script context also gets a variable. We're not actually using the context here, so it will be fine to leave an empty underscore as a way to say, you know what, in this validator, we're not using the context. But I'll leave it here. And we're going to go much deeper into context in Module 205 when we look closely at all the component parts of a Plutus validator. What matters is that this function has a value is equal to the truth value right here. Does the redeemer equal this number? And if it does, this policy is going to validate. The rest of what you see right here is pretty much boilerplate. And I'm not going to go over every detail that we see right here. The Plutus Pioneers course from IOG gives a very good treatment to a lot of how this boilerplate works. And we'll look closer at this later in this course. Anytime you have questions that are not addressed in these videos or in the written lessons, I hope you'll stop by at a Gimbalabs live coding session where we can talk in depth about any questions you have. Now, at the end of this file, we're going to write a minting script. And we're going to write the validator to the output directory, which I can see right here. And we're going to give it some name. In this case, mint secret number.plutus. And you can see this file is already here. So let me just change the file name so we can make another one. I'll save that. And I'm going to press :R at the bottom of the screen to reload the REPL with that change I just made. If I want to use this secret number policy script right here, I have to load it, :L. It's in minting. So if I start to type minting and press tab, it'll autocomplete. And because secret number policy is the only file in this directory or the only exposed module, it autocompletes all the way right here. Once the module is loaded, then we can run functions from this file. And the one I want to run is write Plutus minting script. Write Plutus. I can start typing and press tab for autocomplete. And then I press enter. And if I see that it says write, that means it was successful. And here you can see my new Plutus script right here. Now, you might notice that the structure of this Plutus file is, oh, and I just realized I put the -002 after the extension. That's a little silly. I should have put it over here. There we go. Save that. I can reload this again. And let's just run that function again to get a better named file. Oh, there we go. Mint secret number -002.plutus. Okay, that looks better. Let's delete this one. With this script compiled, I can leave the REPL by pressing Control-D. And now I'm back on the command line. From here, I can change directory into my workspace and then into the repo. And then here's the output folder where my new Plutus script is. So let's CD into output. And just like we were able to create a policy ID from a native script, now we can run a familiar command, Cardano CLI, transaction, policy ID. We specify a script file just like we did in the previous lesson, but this time we're going to give it the name mint secret number -002.plutus. And here's a brand new policy ID for a different sort of token. And that's pretty exciting. Now let's open up the REPL again. The ball REPL once again. Then let's load minting secret number policy once again as well. But this time, let's go back into the source code and let's just change one thing, the secret number. Instead of the golden ratio, let's just make this a 2. We'll save that. We'll reload. And then let's change this to just another number. Save it again and reload. And now let me write the Plutus minting script once again. Okay, and a new file is generated. If I leave the REPL again, Control-D, and I once again CD into my output directory, now I can see that I have a bunch of different Plutus scripts. I've got the currency symbol right here that I just saved. But what I wanted to show you is that if I go back and I run this transaction policy ID command again, let's see, there it is, but with a 3, right? My new file name has a 3 at the end instead of a 2 because it's a different Plutus script. If I run this, notice that I get a completely different policy ID just from having changed what the secret number is. So just like we can change which pub key hash is required as a signer to a transaction in a native script, we can write Plutus scripts where we change just little bits of data and we get different results in terms of the policy IDs we're using. And this is a really trivial example. This is a very simple minting policy. But when you start to write more complicated logic, one of the things that's exciting is that it's not just your validator logic that's defining a policy ID. It's also all of the parameters that you create. This is another concept that we'll explore more in depth in Module 205 when we take a closer look at Plutus. But I just wanted to expose you to this for now as you start to understand how Plutus works. Okay, so we have a Plutus script and a currency symbol. And what I'd like to do is mint a token with this currency symbol right here. To do so, I'm going to work in the PPBL 2024 transaction examples repository, where we've already been working earlier in this module. In Cardano CLI scripts, module 202, you'll remember that we minted native scripts with an automated policy, and there was another one here where you could enter all of these variables by hand. The other file you'll notice is mint native assets with Plutus script. And this one looks pretty similar to the minting transactions we were using earlier, with the changes that I already outlined earlier in this video. This transaction build takes a redeemer and has collateral, but there's no additional required signer. In order to use this script, you have to add your own address and sender key. I have those right here in my PPBL 2024 wallet, and I'm going to add those off screen. Now we're ready to run the script. So we can say mint native assets with Plutus script. I'm going to use the address of my Eternal wallet so I can see the results there. Let's name the token I know your number. How's that? Just one of them. And we'll run the script. If it works, you'll see that you minted the token. You'll see that the fee was a little bit more expensive than we minted a token with a native script, and that's important. And you'll see the transaction was successfully submitted. Now we can wait for this to be confirmed on chain. And here you can see it. One newly minted I know your number token. Wow, that feels a little creepy, but I know I minted that token. Now let's just talk about the idea of a secret number for just a minute. It's actually misleading to say that this is a very secure script, right? First of all, imagine thinking about this secret number right here as a password, right? Once somebody knows it, then everybody has access to this minting policy. But even more importantly than that, all of the details of this transaction will go on chain. And so once this minting policy has been used once, anyone who knows how to read the details of a Cardano transaction will very easily be able to see what the secret number is. So as a matter of fact, it's not a secret at all. However, I hope this is a helpful lesson to help you start thinking about how you can write custom validation logic for any tokens that you might want to mint. Once you really start to use this tool to design systems and applications, this becomes very, very powerful. And I'm excited to see where we can all go with this. As always, if you have questions, be sure to drop by on the Gimbalabs Discord or drop by our live coding sessions, which are all listed at gimbalabs.com/calendar. Thank you for being on this journey, and see you soon.